Hi everyone, thanks for joining me for another video. Today we are going to be talking about parallel lines and transversals. Lines in the same plane that do not intersect are called parallel lines. As you can see in our picture, these are two lines that lie side by side of each other. Lines that intersect at right angles are called perpendicular lines. These lines form a perfect cross. A line that intersects two or more lines is called a transversal. When parallel lines are cut by a transversal, several pairs of congruent angles are formed. And we know the term congruent means the same length or the same measurement. So let's take a look. Here in my picture, I see that my angles that are labeled in orange are all going to be the exact same size. In a similar way, all of my angles that are labeled in purple are also going to be the exact same size as each other. When you are given a transversal and one angle measurement, you can solve for any missing value in your plane. So let's find the measure of angle 1 and angle 2. First, I'm going to label all of my congruent angles to help me to visualize what is going on. So here I can see that 110 degrees is going to be congruent to the measure of angle 1. So I can write the measure of angle 1 is equal to 110 degrees. Next, I'm going to solve for the measure of angle 2. I notice that angle 1 and angle 2 are side by side of each other, and they form a straight line together. So these two angles are supplementary of each other. To solve for the missing value, I need to set up my equation. If these two angles are supplementary to each other, I know the measure of angle 1 plus the measure of angle 2 is going to equal 180 degrees. To solve for x, or to solve for measure of angle 2, I'm going to use inverse operations. So instead of having a positive 110 degrees, I'm going to subtract 110 on both sides. Oh, that looks like a 7, but it's a 10. 110 minus 110 cancels out to be 0, and I can bring down my x. And 180 degrees minus 110 degrees equals 70. So to answer this problem, the measure of angle 1 equals 110, and the measure of angle 2 equals 70 degrees. Let's try another problem. Find the measure of angle 1 and angle 2. Well, I'm given in this problem that one of my angle measurements is 63 degrees. So let's label all of my angles that are congruent to this. Here I can see that 63 degrees is congruent to the measure of angle 1. So I can write the measure of angle 1 is equal to 63 degrees. I notice that angle 2 and angle 1 are side by side and they form a straight line together. When I have a supplementary angle, I know that both the angles that form that straight line are going to equal 180 degrees. So let's write our equation. 63 plus x, and in this instance, x is going to represent angle 2 is equal to 180 degrees. Again, when I have two angles that form a straight line, angle 1 and angle 2 are going to equal 180 degrees together. So I'm going to use inverse operations. I'm going to subtract 63 on both sides. (63 minus 63 cancels out to be 0, and I can bring down my x. 180 minus 63 equals 117. So to answer this question, the measure of angle 2 equals 117 degrees. But what about transversal problems with equations, where you're given variables and you have to solve for the value of x? Well, they're the same as ones that we've looked at before. To first solve this problem, I'm going to label all of my angles that are congruent to one another. Now I can clearly see that 8x plus 10 is going to be the same size or equal to 6x plus 30. To set up my equation that I'm going to use to solve for x, I'm going to write 8x plus 10 is equal to 6x plus 30. Again, the reason that I'm doing this is because in my model, I see that they're the exact same size, so they're equal to one another. Now I'm going to solve for x. When I have my variable on both sides, I'm going to move one to the other side. So to make it easier, I'm going to subtract 6, and I'm going to subtract 6 on the other side as well. 6x minus 6x cancels out to be 0, and I'm left with 8x minus 6x, which is 2x, plus 10 equals 30. Let's use inverse operations to isolate x by itself. I'm going to subtract 10 on both sides of my equation on my equal sign. 10 minus 10 cancels out to be 0. I'm left with 2x. 30 minus 10 equals 20. We're going to use inverse operations. Instead of multiplying, we're going to divide both sides by 2. So to answer our question, x equals 10. Let's do one last example. We're going to solve for x. So here, given my transversal, I'm going to label my angles and identify which ones are congruent, which ones are the same. Here I see that I'm working with two separate angles. So 6x plus 4 and 4x minus 14. If I know that all of my angles labeled in purple are the same and all of my angles labeled in orange are the same, it really doesn't matter where it is placed. So I could rewrite this equation or this expression and I can write it up here, 4x minus 14, because it's the same thing. All of my angles in orange are the same. So now I have two angles that are side by side that form a straight line. I see that I'm working with supplementary angles. I'm going to use what I know about supplementary angles to form my equation. 4x minus 14 plus 6x plus 4 is going to equal 180 degrees. These two angles form a straight line, so they are my supplementary angles. Let's go ahead and combine our like terms. I have 4x and a positive 6x, so together I have 10x. I have negative 14 plus 4, so together I have negative 10 equals to 180 degrees. To highlight what I did is I just found my like terms and I simplified. Now to isolate my variable, we're using a new color now. To isolate my variable, I'm going to use inverse operations. So I'm going to add 10 on both sides. Negative 10 plus 10 cancels out to be 0, so I'm left with positive 10x is equal to, and 180 plus 10 equals 190. I can divide both sides by 10. X is equal to 19. I hope that you found this video helpful. Please let me know if you have any questions that I can answer.